Hey there, ladies and gents. I'm going to do a quick video that will review the QSP problems that we did today in class. So here's my math, and I kind of want to walk you through the process. So when we do a double replacement reaction, we know that we can use our solubility rules, to figure out what the precipitate will be in that reaction. So when I react NaCl and AgNO3, my two products through double replacement are AgCl and NaNO3. I know this is my solid because the back of my solubility rules tells me that when a chloride ion is mixed with an Ag ion, they will combine to form that insoluble compound. But because the amount of precipitate is going to be based off of how many ions of Ag and Cl are in the solution, we can sometimes mix such small amounts together that we may not necessarily see any solid form. So what we can do as chemists is we can predict through calculating something called QSP to figure out if we will actually get a precipitate forming. So the QSP is just a theoretical way for us to determine if we'll actually get a precipitate in a double replacement reaction. So the first thing we want to do is we want to figure out the actual amount of ions that we're going to be putting into the QSP problem. So because all of these ions are +1 -1 charge, whatever concentration we have for our compound is also going to be the concentration for our ion. We'll look at one on the next slide that's not going to be like this. So because I'm adding 0.1 molar AgNO3, that means I'm adding 0.1 molar Ag to my equilibrium. So I can use that to solve for how many moles of my Ag are actually being contributed to my equilibrium by using the molarity equation. I know I'm adding 0.042 milliliters, so I divide by 1,000 to get that into liters, and then I would just solve for moles. So I would do my 0.000042 times 0.1 to get me to 4.2 times 10 to the negative 6 moles for my Ag ion that I'm added. I'm going to do the same thing for my Cl. I'll have my 0.05 molar times the volume, and then solve for X, which gives me 2.5 moles that I'm adding of my Cl minus ion. Now, because I'm adding these two solutions together in my reaction, what I need to understand is the concentration of my Ag and my Cl for the total solution of the reaction, not their individual solutions. So once I know how many moles of each ion I'm putting in my solution, I can divide that by the total volume of my final solution. So I would just add these 2 milliliters together to get 0.542 milliliters and then divide by 1,000, which is where I got these bottom numbers from. And so that tells me that my Cl minus concentration that I've added to my reaction is 0.046 molar, and my Ag plus concentration that I've added to my final reaction is 0.0077 molar. So now I can plug that into my QSP equation. QSP just means it's the ion product, and so it's looking at what the actual amount of Ag and Cl ions is, so that way we can determine if it's greater than or less than the KSP value provided in the textbook. So I put the 0.007 in for my Ag, and I put the 0.046 in for my Cl, and I multiply them by each other, and that gives me a value of 3.5 times 10 to the negative 4th. I went into a textbook, and I found that the KSP for AgCl is actually 1.8 times 10 to the negative 10th. So because this value is greater than the KSP value, that means we will see a precipitate. And because this is so much larger, we would actually see a significant amount of precipitate. So we are putting too many ions in the solution for them all to remain dissolved, so we would see a solid on the bottom. So let's go ahead and let's look at one where it's not going to be a 1-to-1 ion ratio all the time. So this is number 4 on your homework for this evening. So a student prepares a solution by combining 0.025 moles of calcium chloride and 0.015 moles of lead 2 nitrate, and we add water to make a total of 1 liter solution. We want to know if we will have a precipitate of lead 2 chloride. So we're going to do our double replacement reaction. So I have my CaCl2 plus my PbNO3 creating my lead chloride and my NaCls. Now I've defined this as the solid already, so we know that this is going to be the compound that we're going to look at to determine will we get a precipitate when we actually do this reaction. So I'm going to write my equilibrium for that solid. So now we want to do the same thing we did before, is we want to figure out how many Pb ions and how many Cl ions we're actually contributing when we mix all this stuff together. So the first thing we're going to work with is we'll go ahead and we'll work with the Pb ions. So I know that I've got 0.015 moles of my lead nitrate. So because if I look at this compound, when it dissolves, I get 1 Pb and 2 nitrates, this tells me that the relationship between my PB and my compound is 1 to 1. So for every one of these that dissolves, I'm going to get one PB2 plus ion. So that means the moles of PB2 plus that I'm adding is just 0.15 moles. Now I want to get it to molarity, and this time I've got a liter of solution, so I'm just going to do my 0.015 divided by 1 to get me to 0.015 molar PB2 plus that I'm adding into my reaction. I'm going to do the same thing for my Cl minus. So I'm adding 0.025 moles of CaCl2. And now this time it's a little bit trickier because it's CaCl2. I've got 2 Cl ions every time this dissolves. So I need to take this number and multiply it by 2 to get me to 0.02. Oops, that's not right. I can't do math apparently. To get me to 0.05 moles of of Cl minus that I've added into my reaction chamber. Because every time this dissolves, I'm getting 2 of these ions. So if I dissolve 0.025 moles of my compound, I'm actually getting twice as many ions in my container. So I'm going to divide this by my 1 liter again, and that tells me that it's 0.05 molar of my Cl minus ions. So now we can go ahead and we can start to plug those numbers into our QSP. So we have QSP, we're going to just write the expression first, and based off of what we know about chemical equilibrium, because we have 2 of these Cl's present in our chemical equilibrium, we're going to have to square whatever concentration we get for our Cl minus. So our QSP, we're going to put 0.015 molar in for our PB, and we're going to put 0.05 molar for our Cl, and we're going to square that, and that's going to give us a value of 1 times 10 to the negative 4th. So that's what we got when we put these ions, 1.4 times 10 to the negative 4th. So we're going to go ahead and we're going to look up the QSP for this lead chloride in a textbook, and not the QSP, the KSP. And the KSP value from the textbook and or front of your worksheet is 1.17 times 10 to the negative 5th. So if I'm comparing the value of KSP to the value of my QSP, we can see that this number, is it negative 5th or negative 15th? That's right, negative 5th. So we can see that this number is much larger than our KSP. So since our QSP is greater than our KSP, we will have a precipitate. So yes, we will see solid. I hope this video helped. Remember, if you have any questions, you can always come in early for help or shoot me an email. Have a great night.